Alright, so today I'm going to be teaching all the first derivative test. So going over the definition, a first derivative test is something that's going to find your local extrema, which are your max and mins, or your critical points. So all of those basically mean the same thing. One of the things to remember whenever doing the first derivative test, though, is that whenever you solve for them, you're going to find multiple points, which are your critical points, but that doesn't necessarily mean that each of them are a max or min. They could just be a point that doesn't signify anything besides being a critical point. So, getting on into the example. So we have our function right here, which is going to be f of x equals 3x to the fourth minus 4x to the third minus 12x squared plus 3. So taking the derivative, we're gonna I've done right here. We have f prime of x equals 12x cubed minus 12x squared minus 24x. So whenever you're using the first derivative test, obviously given by the name, you're going to take the first derivative, and then you're going to set the whole thing equal to 0. However, before you set your function equal to 0, see if you can factor anything out, because that's always going to make your life easier, and it's going to help you ensure that you're not dividing out any possible x values or anything. So this is a way to help yourself clear all your areas. So I factored out a 12x, which is our greatest common factor. So once you factor that out, you have 12x times x squared minus x minus 2. And you should recognize that that is another factorable equation. So I already factored that out right here. So that little inside parentheses factors out to x minus 2 times x plus 1. So now your new factored out thing would be 12x times x minus 2 times x plus 1. So now, if you look at it, we kind of have three separate components. So we have this 12x and then the x minus 2 and x plus 1. Excuse me. So we're going to set each of those equal to 0. So here. I already did that right here. So as you can see, I showed that I was setting each of them equal to 0. And also, forgot to write this, but you're going to want to show that you're setting your whole derivative equal to 0, so go ahead and put in equal 0 right out there. So setting each of these equal to 0, I got three different x values. So I have x equals 0, x equals 2, and x equals negative 1. So each of those is a critical point. So whenever you're solving, you're going to want to go ahead and define those two out with your answer, just to make sure that your teacher knows that you're getting all the critical points right. But then you need to test if they're a max or min, which is part of the first derivative test. So now we're on to that little second part. So the test for this is going to be using a number line. So you're going to want to draw yourself a number line down here and label it f prime of x, because that's going to help you remember what to plug these numbers into later. So once you make your number line and you label it f prime of x, you're going to plot each of your numbers. So as you see, I've plotted the negative 1, 0, and 2. And doing that, you need to test to see if the function to the left and right of the number is positive or negative. So I use outrageous numbers doing this. Excuse me. Just because it makes it easier to distinguish. So plugging in the numbers, say plug in 100. You see, and plug it into your factored out form also. That's another key thing to remember, because it's going to make your life so much simpler and faster. So plugging it in to 12x, you know that's going to be positive. And then 100 minus 2 and 100 plus 1. Those are both positive as well. So you know that that whole thing's going to be positive. So I went ahead and put a positive sign out there. And then you're going to do the exact same thing in between each other number. So once you've done that, you can see that it makes your life really simple from this point. So negative is going to mean a negative slope. So right here you're going to be going negative, and then you're going to a positive again, right? So positive. So that makes a V shape down here, and that's a minimum. because, as you know, a minimum is going to be like that, and a max is going to be at the top of a graph like that. And then over here, at the 0, we're going to be going from positive to negative, so it's going to be a max. And the 2, we're going once again back negative to positive, so it's going to be another minimum. So now you've defined all your critical points, and you've proven that each one is a max or min. But you can't always assume that, because sometimes you might be plugging them in and you might have this as a min, but if this negative right here is a positive, then the 0 and 2 are just critical points. They're not maxes or mins. So don't get ahead of yourself. But even though you just did a lot of work to prove simple stuff, you still have one more step to do just to cover yourself. So, and I would recommend writing this for every critical point just to make sure. So once I do this, as soon as I find my critical points, I go to the bottom of my space, my workout space, and you need to write, by the first derivative, since the point x equals blank, you're either going to say changes from negative to positive, or positive to negative, or you're going to say doesn't change at that point. So since, by the first derivative test, at x equals blank, since, let's say, changes from negative to positive, then x equals blank at the point. So then you're going to have your parentheses of your x value, which is the critical point you found, and then plug it back into the original function to get your point. So at the point blank, x is a max / min, or if it's nothing, then you can say since it doesn't change signs, then it is neither a max nor min. So the numbers that you're going to have in that sentence you're writing is going to be your critical point, so x equals blank, and then next to that you're going to have the point. So it's going to be x and then f of x, which is going to be plugging it back into the original equation. So going back to our example, the point you would use to explain your point 0 would be at x equals 0, comma 0, 3. Plugging that back in here. X is a max. So that's all the steps to solve the first derivative test. Just make sure that anytime it says local extrema or max or min, critical points, that's all going to mean using the first derivative test. So make sure that you can recognize any of those forms. And then also remember to not assume that each critical point is a max or min, that those could simply just be points. And then lastly, don't forget to write your sentence explaining how you got that point and by which system you use. So in this case, it's using the first derivative test. So I hope that you learned how to use the first derivative test on problems. So yes, bye.